Okay, the primary reason behind tonight's event is really to showcase the New Zealand Experimental Economics Laboratory, known colloquially as NZEAL, and also to demonstrate how experimental economics research can be used to enhance the effectiveness of policy decisions taken by both private businesses, but also by governments and other public agencies. The New Zealand Experimental Economics Laboratory, based here at the University of Canterbury, is a state-of-the-art facility which is unique to New Zealand. It hosts a very active experimental economics group and attracts many renowned academic visitors and scholars. Its members produce research on various important topics, including the behaviour of firms, bargaining, environmental policy, and regulation. Now, whilst as PVC I'm delighted that the establishment of NZEAL has boosted the research productivity of my colleagues, the lab has far greater potential to benefit the whole of New Zealand. In particular, it can be very helpful in designing new institutions, as well as test bedding and fine-tuning economic policies prior to their implementation in order to ensure that they actually do bring the anticipated benefits. The annual NZEAL Distinguished Lecture Series invites eminent guest speakers from around the world to discuss the latest developments in experimental economic research. And it is both a pleasure and a privilege to invite Professor Joep Sonnemans to present this evening's 2013 NZEAL Distinguished Lecture. A prominent experimental economist, Joep is Professor of Behavioral Economics at the Faculty of Economics and Econometrics at the University of Amsterdam and a faculty member of the prestigious Centre for Research in Experimental Economics and Political Decision-Making. Professor Sonnemans graduated in mathematics and social psychology from the University of Utrecht in the Netherlands. He went on to work as a researcher on social security in the Ministry for Social Affairs and as a research associate in psychology at the University of Amsterdam, where he obtained his doctorate. He's published over 50 articles in international economic journals and is a member of the editorial board of Quantitative Finance and the Journal of Economic Psychology. He's mainly interested in experimental research in which insights from economics and other social sciences, for example, psychology, are combined or contrasted to help explain and understand various types of social behaviour, including, for example, how individual expectations are formed and how people behave during the bargaining process. The specific question that he will address here this evening is how can experimental economics help judges to better understand evidence provided in court by forensic evidence experts in order to minimise wrongful convictions. And I think we would all agree that's a very important topic. So, just to say before I invite you to the lectern, there will be an opportunity after the presentation for everyone to ask questions. So if you could just keep your questions in mind, and then I think you'd like to take them all at the end. Okay, thank you very much. So I'll just hand this over to you.
Thank you. Okay. Now, thank you very much for the very nice introduction. I feel honored to be here. So the other side. In fact, this is the start of a sabbatical for me. So I started in New Zealand, and as an experimental economist, if you go to New Zealand, you have to go here, of course, because here is the lab of New Zealand. What I'm talking about today is these questions. It is about the misunderstandings between judges and forensic experts. Most of the work which I will present is with Frans van Dijk and Eddie Bouw. Frans van Dijk is a former colleague of me who was also originally an experimental economist, and he at some point went away from academia, and he's working now at the Council of the Judiciary. And in the Netherlands, that is the organization that stands between the government and the courts. Because of the trias politicas, you don't want to have politicians to have any voice in what's happening in that system. So they are in between. So that's for partly that's more a management kind of thing, but partly it's also policy making. So he is director there of the policy formation and also research. Eddie Bouw is, especially in the second study, he is also working at the Council of the Judiciary. He is a judge, and he's also a professor in the law school in the University of Amsterdam. And he's also in the Council of Judiciary. He is especially the one who makes up procedures in courts. So he's also very much interested how things work in practice and if we should change things in that. Okay. Now, what's the problem? What's the problem we have here? Now, very simply, one of the tasks of a judge is to make a decision in a criminal case, guilty or not guilty. And they should do that based on evidence. Yeah? Just not just, oh, nice face, not guilty, and things like that. No, it should be on evidence. Yeah? That evidence is more and more technical, because forensic experts and also the kind of techniques they use is much more and more science founded. And especially it is more and more probabilistic. That means that these experts typically will never say, yes, this person is clearly guilty according to this evidence, or not guilty. No, what they give the judge is some kind of probability. It is very unlikely that this evidence will come forward if this person would be innocent, for example. And they use numbers in that. Now, judges have in practice problems understanding these experts. Sometimes they realize that they don't understand them. Sometimes they don't even realize that. They think they understand them, but the experts think they are not understood. Yeah? So that is frustrating for both the judges and also for the forensic experts. Yeah? Now, just by accident, what happens is that a very good friend of mine, who was originally an experimental physicist, after his PhD, he became a forensic expert. So I knew already some people working in the Forensic Institute in the Netherlands, and I heard them already talk about stupid things that happens in courts, judges that they completely misunderstood them and things like that. After that, when Frans van Dijk told me, we have this problem, and we don't know what to do with it. We even don't know how to get information about this problem. What is really the problem? What are the most important things of this problem? Then I realized, now this is really a nice topic. Now, just to give an idea what kind of things you have to think about if I'm talking about evidence, I've just formulated some examples. Now, imagine you are a judge in a criminal case, and you get an evidence like, now, this suspect had clearly a conflict with the victim, who's murdered, for example. Now, is that the kind of evidence that's very important? Now, probably that is the kind of information that's why this person is a suspect, because they first look at who has motives to murder this person. But if this victim has many conflicts, then it doesn't mean anything. You cannot say, now this person is guilty because he had a conflict, of course. So it is just only one of the small things. But I printed it in red here because it's quite negative for the subject, of course. Other case, suspect was not recognized in a lineup. This is a very old picture. I took it from internet. Nowadays they do it a little bit differently. And they have very strong procedures about that. You should have at least 6 people, and they should be more or less alike and things like that. Now, these lineups, so you have a group of people, and the witness has to find the one the witness saw at the place of the crime, for example. Now, they have done a lot of research about that. So they know, they have all tables and things like that, they have the procedures, but also tables. They know how likely it is that someone who did it, so was the perpetrator, is not recognized by the witness, given the circumstances, bad light or whatever. Yeah? So now in this case, imagine you get the information, suspect was not recognized in the lineup, so that's positive for the suspect, of course. And experience tells you how likely that is. So how likely is it in these circumstances that, that somebody who did the crime will still not be recognized? These are more probabilistic evidence, so you're not sure. It is not that you are sure that this person, that this suspect is not the perpetrator, just because he's not recognized, he can still be the perpetrator. Now, something what happens very often is videotapes nowadays. In gasoline stations or supermarkets, you have these videotapes, video cameras, and for one reason or another, the tapes are almost always very bad. I don't know why. Probably they never clean the cameras or whatever. So what you have these shots of a video, and what experts can do, they can try to measure. For this person is not recognizable. Yeah, you cannot see anything of what kind of person it is, but you can try to measure the head, how long this person is. So what they then do, they have all technical stuff for this, and they go to the shop itself and use the same camera, and then they come up to some limits. For example, they say, now the perpetrator is according to the very likely between 1.60 m and 1.75 m. Now, the suspect is in this range, but is this very important evidence? Is it very incriminating evidence? No, of course not, because there are a lot of people who are in this range. Yeah? So this is a kind of evidence that is so weak that it is not usable. But this is also a nice example of a very asymmetric situation, because what happened if the suspect was not 1.70 m but 1.90 m? Then it would be a very strong evidence that this suspect is not guilty. Yeah? So very often these things are quite asymmetric. Another example from real life. This is from a famous Dutch murder case where the suspect, there was a widow, a rich widow without family, was murdered. Her financial advisor was one of the suspects. He said he was at the time of the crime, he was not in the city where the widow lived, but he was driving a car about 20 or 30 kilometers away from the city. The police had the information from the mobile phone, from the mobile phone companies. So what happened, that his mobile phone was registered by an antenna in the place of the murder. And then, of course, the question is, can that happen? Can that happen if you are away from a place that still, for some reason, the signal of your phone is not taken by the antenna just next to you, but somewhere further away? Now, in principle, that can happen. Yeah, under certain circumstances, in principle, in theory, can it happen? So what happens now? These experts, what they do experiments. They try with different weather conditions and in different situations, they try if they can reproduce that. And they can, in the end, they tell the judge, now it is in theory possible, but we cannot recreate this. We cannot find it in all the things we tried, it didn't work for us. We were not able to create the circumstances in which it happened. Now, that's, of course, incriminating evidence, especially if you really think this is strong evidence, then you also believe, now this suspect was lying, apparently, that he was not in the city. And why would you lie if you didn't do the crime? So that's a little thing. But this is also talking about probability. A fifth example. Let's say a body is found in the Netherlands, typically in a canal or a river, and then the careful study of the body, you find some carpet fibers on the body. Now, there is a suspect, and the suspect has a carpet with the same kind of fiber. Yeah? So that is suspicious, to say. But how strong is that evidence? Now, of course, this depends a lot on how common this carpet is. Yeah? If this is an IKEA carpet, which a lot of people have, then that the suspect had this kind of carpet is not very incriminating. But if it is a quite rare carpet, then it is. Yeah? So what here also, this is also an example that what you really have to look, the strength of the evidence, is determined by how likely that you find the evidence when the suspect is guilty, compared with how likely this evidence is if the suspect is innocent. Yeah, that's more or less what you compare. If it is a very common carpet, that even for an innocent person, it's not unlikely that he has this kind of carpet. Now, experts play a role in the interpretation of pieces of evidence. So one medical expert gives this evidence, then a physicist gives another kind of evidence, but the judge has to combine all the evidence. Yeah? And then reach a verdict. Of course, there are a lot of other problems that judges have, more of law kind of things, how to interpret it, is this homicide or murder or whatever. I will not talk about it. This is just how to interpret the evidence. Is this person guilty or not? Yeah? Now, this is a special case of a very general class of problems, which is studied a lot in economics. That is decision maker and uncertainty. These are situations in which the decision maker can never be 100% sure that the decision is the best decision after all. But he just tries to make the best decision possible given the information that he has. Okay. Now, from the examples you already saw that we only focus on criminal cases. Yeah? But you can imagine that in other cases, in civil cases, sometimes also you have the same kind of problems. Now, what is the task of the judge? Very simple. You have the evidence. Given the evidence, what is your verdict? Is the suspect guilty or innocent? Now, the evidence, as I said, is in practice always probabilistic. Can be incriminating, so against the suspect, or exonerating, so evidence that the suspect is probably innocent. And the combination of all evidence only leads to a conviction if it is strong enough, combined, incriminating enough for the judge to say, now I think this suspect is guilty. And in the United States they call it beyond reasonable doubt. In the Netherlands, this is an English translation, lawfully and convincingly proven. Now, this is quite fake. This is not that the law says you should be sure for 99.5% or 99.7%. No, it is quite fake. Nevertheless, to study this, to model this, you have to be more concrete. Okay. What is the normative process? That is what I mean is how should the judge work? And that is also what most people agree on how it should be. The idea is that this evidence leads to a belief of guilt, and this belief of guilt for the judge leads to the verdict. Yeah? Looks quite logical. Nevertheless, there is some evidence with interviews with judges that some judges say, oh, I don't know, I just listened to this, and then at some point I think guilty, or I don't think it's guilty. And then when I'm writing the verdict, then I just make the story, make it a round story. This is not how it should be, of course. And I find it amazing that some judges admit that they work like that. It also means, I call this a Bayesian judge. That's only for the people who have done some statistics. Bayes was a mathematician in the 19th or even maybe 18th century. Who was the first one to write about how beliefs are formed based on new information. So what happens is that you need an initial belief about guilt, and it can be very low, because I don't know anything about this person, so I think it's a very low probability that this person is guilty. And then with each piece of evidence, I update my belief. Yeah? So if it is an incriminating evidence, I start to thinking it's more likely that this person is guilty. If it is an exonerating evidence, then I think it is less likely that this suspect is guilty. Now, at some point, after all the evidence that's available is used for updating, then the judge looks, according to this model, at his belief and thinks, now, this is not strong enough. I think it's quite likely that this suspect is guilty, but it's not strong enough. I acquit this suspect, for example. Or the judge thinks the belief in the end is so strong that this suspect is guilty, is above a certain threshold, and the judge convicts. the suspect. Okay. Now, what aspects of the problem make this a difficult problem? Now, first to start, most cases are not difficult. In practice, in most cases, either all the evidence is of the same kind, most of the kind incriminating evidence, so there is not much, so it is only, is this enough evidence, but not, there are some kinds of evidence that go against each other. And in that case, it's relatively simple. And in fact, most cases are simple. But once in a while, you have quite difficult cases. And then it's still, of course, very important that the judge makes a good decision. Some cases are very hard, especially when there are two kinds of evidence, and also evidence of different strengths. Yeah, we have already talked about it, that, for example, with the carpet fiber, it depends how common this carpet is, and that also determines how the strength of the evidence. Okay, forensic evidence have become more scientific and the reports more precise, and also more precise also in a probabilistic sense. They motivate how they come to these numbers. And one reason is that they wanted to become more precise. They wanted to become more like science, in a sense. But also because in the past, in many countries, there was only one institute that did forensic research. But that's not really fair, you could say. So it is nowadays, especially suspects, can also hire other forensic experts. And then have two parties with both their own forensic experts. And what you don't want is that you get a whole lot of discussion in the courtroom about all these technical things. Yes, and that means that you more or less need a template, a kind of rules in which this evidence should follow. Okay. Now, judges have typically no background in statistics. That's not so strange. It is not in law school. Yeah, and that's, in fact, is a little bit strange. If you think in, well, whatever you study in university, almost all studies as a student, you learn something about statistics because you learn about hypothesis and hypothesis testing and different kind of errors. And you learn that if you study biology, but also if you study languages or whatever, as soon as something is about hypothesis, you talk about hypothesis testing and you have a little bit of statistics. In law school, they don't do that. Yeah, in law school, you read laws and you try to understand why the law was this way or not another way and things like that. So that means that if somebody after law school becomes judge, what he or she is doing is testing hypothesis, guilty or not guilty, but he just has chosen the one study in university in which you don't learn how to test hypothesis. To put it a little bit strong. The people of the lawyers are in the audience. I will get some questions about this probably. Another very important thing is that judges typically don't get feedback. If you make an error, you will not learn from that. If you acquit a suspect who was the perpetrator, who was guilty in fact, you will never learn in most of the cases. Because then the judge says, now this is the evidence not strong enough, so I acquit the suspect, then the case is over. And you will never learn it. The other way, in which an innocent person is convicted, in very many cases probably, it is also never found out. Only rarely when there is new evidence. Yeah, you have especially in this in the United States, you have some universities that work on these cold cases. People are already 20 years in jail, and then they find out now that this cannot be the perpetrator. But that's quite rare. So these judges, in their career, they never get feedback about how correct their decisions are. So that also means they cannot learn by doing. Yeah? So that's difficult. It has another consequence. That is because if the judge doesn't know for certain if someone is guilty or not, also we don't know. Dus if you look at real world data, you can think there will probably be errors, but you don't know exactly what the errors are, of course, yeah? Because we also don't know these things. And that's the reason to do experiments. Now, what kind of errors can a judge make by combining evidence? Now, one of the possible things, this before we started doing the research, we were thinking about this. What kind of things can you expect? Now, what you could expect, for example, is if somebody thinks, now, weak evidence, I ignore that. That's too weak. Just ignore that. And that's also too weak. I also ignore that, etc. But of course, many pieces of weak evidence should make strong evidence. Another kind of mistake, just the other way around, is that you ignore the strengths of evidence. You only look at how many pieces of evidence are incriminating and exonerating. And then you can general over or underestimating of probabilities. That's possible. So this is about the probability part, probability of guilt. And there's also possible that you make an error in the step from probability of guilt to the decision to acquit or convict. In the field, you can never really find how often this happens because you don't know the threshold of the different judges. In an experiment, we can manipulate that, and then we can just see how often they make a mistake and what kind of mistake. So the first study, the question is, do subjects make systematic errors in determining the probability of guilt? And then, do they make errors in the step probability of guilt to decision, so the second step? And the background, because we were a little bit afraid that especially people who had came from law school had problems with this. So we compare science students, social science students, students from the law school, and more specific, honor students from the law school, so the best students from the law school, and candidate judges. Originally, we wanted to do the experiment with judges. But we started with students because you don't have so many judges, so you cannot do an experiment and think, oh no, should have done it differently. I come back to the judges. Now you have to do it right directly. So we decided we first try it with students, and afterwards we go to the judges. But then we didn't get permission because they saw what we already found by the students. But we could do it with candidate judges. And these are people who finish law school and want to become a judge. Then they get a job in the Netherlands. They perform different kind of tasks in the courts. And every month they have for 2 days they go to courses and things like that. And after 6 years they are a full judge. We could do the experiment with these candidate judges because they were not afraid if these people do badly. They say, of course, these are not judges yet. They are learning to be judge. It was fun the moment when we asked to use judges for the experiment because they didn't allow us, and then Frans van Dijk, who was working it, why do you really think they are bad in this? And then they had to admit, more or less, that they saw that. They were afraid for that. Okay, and the second study, so these are individual judges. The second study is inspired by the fact that some cases in the Netherlands are, we have 1 judge, and in some cases we have what we call a chamber of 3 judges. Yeah? And the question was, do they perform better? Very likely, we thought. But also, is this difference caused by wisdom of crowds? What I mean with that is that if you sometimes make just a stupid mistake, if you are in a group of 3, it's very unlikely that 2 or 3 people make exactly the same mistake on the same moment. So as a group of 3, you will also do a little bit better because of that. Or is the difference also caused by the discussion in the team, yeah, in the group? And one of the nicest things of the second study is, do we find if our participants in the experiment, if they have function in team decision making, so in groups of 3, does that also improve their decisions in individual cases where they are alone? And that's important because for judges, because they don't get feedback, they cannot learn from how well the decisions are, but probably they can learn from the discussions with others. Okay. Now, so we did an experiment. It's clear why we did an experiment, because we don't have field data, and we cannot get field data because it is always impossible to know with certainty whether a decision is right or wrong in the real world. But in the in an experiment, we can just create a situation. And because we create it ourselves, we can make sure that we know what is the right decision, and we can compare the decisions made by the participants in the experiment with the optimal decisions. So we do this first with students, and after that we did it with candidate judges. So it is an economic experiment. Just a few words about this. In an economic experiment, what you do, you create a situation that you completely control. You try to have, you don't want noise from the outside world, to say, so you make it a very clear situation. That also means that you simplify the situation, but you try to do this with the essential elements still there. And that, of course, is a little bit subjective. It's always where you can discuss with others. No, I think you did it wrong. You should put this and that. But that's what we always try. Then we always incentivize. People earn money in economic experiments. Now, one reason, of course, otherwise they wouldn't do it probably, but the most important reason is we want to have control over preferences. If you say in this situation you earn so much and in that situation you earn only so much, then very likely people prefer the larger amount, so you have control about the preferences. Well, if you wouldn't have incentives, then you don't know exactly what the preferences are of the decision maker, and you also don't know whether the decisions are wrong or right. And of course, a very nice element of experiments in general is that you can replicate them. So that's with field data, you can be happy if you find field data, but then you have only this data. With experiments, others can also do the same experiment or make small deviations from that experiment to see how robust it is and things like that. So it's like in the sciences where you do experiments. So what we designed, the decision problem, we wanted to do it in a way that we very clearly defined the evidence, pro and contra, and also how weak and strong the evidence is. That takes a lot of explanation for the participants. We also needed enough difficult cases. What I said, in real life, many cases, most of the cases, maybe 95% of the cases are quite simple in this respect, but there are a few cases that are difficult. We chose our parameters in the experiment such that we have about one out of 3 problems are difficult in this sense, just to have enough data. And because we have defined everything in an unambiguous way, there is an objective right decision in which we can compare the decision with this right decision. Okay. Now, what are good decisions? Of course, convicting a perpetrator, that's a good decision. And acquit an innocent is also a good decision. Now, what are the wrong decisions? Now, let's start with this one. Acquit a perpetrator, that's bad for society, because that means that the perpetrator is still around, maybe doing other crimes, and also there's no justice done. That's bad, that's negative. But convicting an innocent person is even worse, because if you convict an innocent person, then also there is a perpetrator walking around probably, and also no justice is done, but also an innocent person is in jail and has a lot of problems for the rest of his life probably, because he's once been in jail. And also it is costly for society to have somebody in prison who doesn't belong there. Now, so you have 2 kind of verdicts, conviction or acquit. The real situation that the suspect is the perpetrator of the innocent, these are the numbers. So this is negative. B should be very much more negative than this one. For the experiment, we choose some numbers. That's what I said. We use money to manipulate, control the preferences. So every time they made the right decision, they earned 100 points, which were in fact euro cents. So they earned €1 for every right decision. But if they acquit the perpetrator, they lost €3, which is bad, of course. But if you convicted an innocent person, you lost €15. So that means if you do that a few times in the experiment, more likely you don't earn any money. Yeah, you could even make a loss. Now, if you fill in these numbers. Then you can just calculate, I just won't do it here, but you can calculate that if you are risk neutral and you want to maximize your expected earnings, you should only convict suspects in which you think that the probability of guilt is 80% or higher. And so that's how we choose the parameters. Okay. Now, about the evidence. What kind of evidence do we give them? Now, this is the idea. Evidence is more incriminating if the probability of that evidence is high with a guilty suspect compared with this probability with an innocent suspect. If you think about the fever, carpet fevers, if it is much likely, if it is quite rare, for example, this carpet, that means that it's very, if this suspect has this carpet, let me say it the other way around, if the person is guilty, then he has this carpet, otherwise there should not be these fevers on the body. And if it is innocent, he still can have these fevers, but if it is a rare carpet, that probability is quite small, and if it is a common carpet is quite large. Now, so the strength of the evidence, this notation in statistics is quite, this means a conditional probability. So the evidence, the probability that you find this evidence if the suspect is guilty, that's above above here, and this is the evidence, the probability of the evidence is if the suspect is not guilty. So how this compares gives the evidence. More specific, if the strength is larger than 1, then it is incriminating. So there's a kind of evidence that you typically would find by guilty people. And smaller than 1 is exonerating. It's the kind of evidence you typically would find with innocent people, innocent suspects. Okay. Now the normative benchmark, I was talking about the Bayesian judge. Yeah? This is Bayes' rule. Or is caused by Bayes' rule, you could say. What is this? Now, you have a subjective idea that this suspect is guilty, and so 1 minus that probability is that he is not guilty. Now, the probability of guilt of guilty subjects divided by the probability of not guilty we call the odds. Yeah? Just like gambling. Now, very nice in this Bayesian rule, what you find is that if you, this is before you see the evidence, if you see the evidence, then your new odds should be the old odds multiplied with the strength of the evidence. In other words, if the evidence is incriminating, that means that this is larger than 1. That means my belief that this subject is guilty, the suspect is guilty, increases. If it is smaller than 1, it decreases. Yeah? Now, we don't expect that people, that decision maker exactly use these numbers. But what they should do, they should react in the right direction. And they should use a stronger evidence, also interpret as a stronger evidence than a weak evidence. And that's more or less what we compare. Now, if you look at, take a little bit of water. If you look in the literature about experiments with judges of juries, what you very often see that they make scenarios, they make complete stories with pages and pages long, and then they ask people, what do you think is happening? But then, of course, you are not sure what they should do. So what we do, we have no stories or scenarios. We use very precise info from experts. Yeah? That's how we model it. So we give probabilities. The idea is that there are 3 kinds of inquiries, and the possible outcome is always incriminating or exonerating. Now, for example, the first one, if the accused is the perpetrator, then in 84% of the cases you will find an incriminating evidence, and in 60% of the cases exonerating evidence. This should add up to 100%, of course. If he's innocent, then in 64% of the cases, you will find the exonerating evidence, and in 36% of the cases, the incriminating evidence. Now we do that for 3 different type of inquiries. What you see is this asymmetry, with the example of the height of the suspect in the video, in the bad video shots, in which we said, now if we find the suspect should be between 155 and 170. Okay, if it is in between there, if you find that is not very incriminating, but if you find that he's longer than that, that's very strongly incriminating. Now, that is an example of study 2, where this is very innocent. It is very much more helpful if it is innocent than when he is guilty. It looks a little bit complicated, but in the experiment we explained it very extensive, and then we ask a lot of questions to the people that they really understand how this works. So we ask them about numbers. They have to look it up in tables and things like that, so they really understand what it is. So these 2 are asymmetric in a sense. This one are symmetric, but not so strong. The strength of the evidence is this divided by this. So you see, this is the strongest evidence, incriminating evidence. Then you get this one and then this one. And of the exonerating evidence, this is very strong. Then you get this and then you get this. And that we help them in this. That the code we changed the size of the font size. That they just remember when they see the evidence, oh, this is quite important evidence, this is weaker evidence, and this is still weaker evidence. Okay. So they have to make decisions for 30 cases. And they have to make 2 decisions, to convict or acquit, and also they have to give a probability of guilt. Each period we pay only one of the 2 decisions, because we didn't want them to hedge. Yeah, if you think, now I'm not sure. Now let's say I think he's very likely to be guilty, but nevertheless I acquit him, then one of the 2 decisions will be right. You don't want that. So that's why we say only one of the 2 will be paid, and you will only find out in the end. Outcomes only after the last period. So just like in the real world, they cannot learn by doing, because they don't get feedback. Yeah, so they don't get feedback what are right decisions or not. After a pilot, we decided to pay him also a salary of €1 per period, because otherwise many people would make losses. That was not what we like, because then students will not come back to our lab. This is what we explain to I will just skip this one. This is how we explain how we form the evidence, so they can really understand how it works. Now this is what they see on the screen. This is a translation of the computer screen. For example, period 2, there are 6 pieces of evidence. 2 are exonerating and 3 or 4 are incriminating. We always sort them, so they are not order effects. And then they have to make the decision, either acquit or convict. We remind them on the consequences. If you convict but he's innocent, you will lose €15. Here you will lose €3 with a wrong decision. And they also have to fill in the estimation of the probability of guilt. Okay. Now, the results. First about the probability. How well did he do? Now, there were some participants with too little variation to use the data at all. They always said 50%. Whatever the evidence was. So they didn't believe anything of the evidence. 90 participants misunderstood the task because apparently they, instead of reporting the probability of guilt, they reported how sure they were about their decision to acquit or convict. Because then you saw there were some cases were extremely simple in the sense that there were only exonerating evidence. So everybody makes a quit decision, but nevertheless they say 95% probability of guilt. Now apparently they mean something differently. They mean I'm very sure that this person is innocent. So we had to remove these also from the data. Now for the other 182 participants, the probability estimation was quite reasonable. I was not disappointed by that. Just to give an example. Here we have, for all the 30 cases, the objective probability, and here we have the average subjective probability. Now what we see that it is, in general, nicely increasing, but we also see that it is too close to 50% always. So they underuse the evidence. Now we can also analyze it for the whole group, but also for each person, because we have 30 decisions. We can try to measure their subjective strength of the evidence. That's here. So this is how it should be, and this is on average how it is if we take the whole group together. Then we see that the order is right, so a strong evidence is also seen as a strong evidence and a weak as a weak evidence. But you see that this is smaller than 4, this is also smaller, this is also smaller, so closer to 1. And this is too big, too big, too big. Or the accelerating evidence, they underestimate the strengths, and also with the incriminating evidence, they underestimate the strengths. But the largest mistake is here. This is very strong accelerating evidence, and they don't use it like that. They use it as a relatively weak. Still stronger than the other two, but nevertheless relatively weak. We also see that they realize that convicting an innocent person is not a good idea, but apparently many people did it in another way, not by changing the threshold, but changing the way they use the evidence. Because based on this here, the estimation, you see on average 50% should be guilty, how we made the situation. The baseline is 44%. So it looks like that, although they know that the baseline is 50%, they think, oh, let's be a little cautious, go in the direction of 40%. And then if the evidence comes, they also underestimate the incriminating evidence, so they don't go enough to the guilty part. But also, if you have accelerating evidence and you have a combination of that, then they also they use a strength, a subjective strength that's too low. In general, the strength of evidence is underestimated, and that's stronger for accelerating evidence. Partly combined with this, it is not so bad. In fact, what we didn't find, what I personally expected to find, was that this weak evidence, this evidence and this evidence, would be ignored more or less. It's weak, so let's ignore it. But that didn't happen. They really use it. So combinations of weak evidence is indeed used like a strong evidence. Decision to convict. Now, we can look at the objective probability of guilt and whether they convict or not. Now, remember, if they are risk neutral, so it would mean that for all these cases, up to 80%, they should acquit. And only if the probability is 80% or higher, they should convict. So this line should go like this. Now, this is not so bad, but these are very bad. So that means that subjects who are a little bit in the direction, there's more incriminating and accelerating evidence, but not so much, they are still convicted in 30–40% of the cases. That's really bad decisions. Then you can think, now maybe this is based on the objective probability, but of course they should base it on the subjective probability. It can be that they make the wrong estimation of guilt, but then make the right decision given their belief. Now that's this line, that's even worse. So it looks like, for example, what happens that somebody with some case, let's say with a objective probability of guilt of 70%, they underestimated, I think now I think it's 60%, but nevertheless I convict this person. That's what happens. Now, not all errors are as serious as other errors. If you make an error, so the threshold should be by 80%, but if you convict a suspect with an objective probability of 75%, the expected error is smaller, of course, than when you convict a suspect with a very low probability of guilt. Now, what is the measure we take here? It's just the earnings, expected earnings. So the expected value of a decision, given the probability, given the evidence, minus the expected value of the right decision. Then we have the errors in cents per decision. Now, on average, it is 60 cents. So that's not so good, I guess. If we look at the different kind of students, then we see that science students, other social sciences are psychologists, most of them, and economic students, that doesn't make a lot, it is almost the same. Then we have honor students in the law school, they make a significantly larger errors. And then we have the candidate judges, they are somewhere in between, but still more than our students in economics or science. The nice thing, this we have already a result of this in the sense of policy. After they saw this, the coordinator of these courses for candidate judges, they decided we really need some statistics in these courses. So that's very nice. That's very nice. It's very rare as a researcher that you have an immediate influence on the real world. This is about the decision. You could also do the same analysis for the probability, and then you don't see a difference between the groups. Okay. How long do we have? Cool. Okay, the second study is, in the second study we compare the decision making by individual judges and groups of three. Now, that is what I already told you. That depends, both cases are common in the Netherlands. It depends not on how difficult the case is, but on the severity of the case. So if it is for murder, for example, typically you have 3 judges. If it is more like embezzlement, there's only 1 judge and things like that. Now, not this government, but the government before that, they decided we should spend less money in the court. So what we do, we will have more cases treated by 1 judge instead of 3 judges. There was, and then everybody would guess that also would mean lower quality of decisions, but it's very hard to measure that, to make this a strong case. So that's a good point to do this in experiments. So in the field you cannot measure that, correctness of the decision, so it's a good case to do experiments. Now, we use exactly the same problems, but now we have also groups of 3. Now, the research questions are, do these groups of 3 better? Is the difference, there's already talk about this, is that caused by the wisdom of crowds or the discussion? And importantly, do participating in team deliberation also means that you better understand the problem and you do better in individual decisions. Now the treatments we use, the individual case, we just took the data of the previous experiment, but only for not for the candidate judges, and also not for the honor students from the law school, but only for the normal students we normally have in the lab. Yeah, the law school is in another part of the city, so normally we don't have many law schools in our population. Now for these new experiments, what we did, in every case, they get all the information, of course their whole explanation of how we make this evidence and things like that. Then every period, they first have to make an individual decision and an individual probability of guilt. Then there is a group discussion in a chat box, yeah, so they are typing and they can talk to each other by typing, and students nowadays do that very, very fast. And then they vote for the group decision. Now they can only start voting when everybody made a contribution, because that's also a reality. Even if you think I'm so completely sure about what to do, I won't listen to you. You cannot do that in the chamber of 3 judges. You have to. Everybody has to give his opinion before you can go to a decision. So the vote for the group to acquit or convict is made by just majority voting. The probability is the median probability of the three probabilities that they hand in, and that's because we don't want strategic behavior. If you think that for example, if I think that the other two judges have the tendency to have a too low estimate and I want to have a higher estimate, if you would take the average, I could say 100% even if I don't believe it is 100%. Now this kind of strategic behavior you don't have if you ask for the median, so that is the middle of the three probabilities, because if I'm an extreme, it doesn't matter what I choose. Yeah? Now, so this means 4 decisions for every case. Only one of the 4 decisions is in the end paid out. Randomly determined, and of course they don't know beforehand, and also they get no feedback. Now what can we compare? What kind of variables do we have? Now I don't look at the probability here, we also studied that. We didn't find much difference between groups and individuals, so we look only at the decision to acquit or convict. Now this is the individual decision making in the group treatment, so that is the decision the participant makes before there is a group discussion. Then you have the group decision after discussion, and then we have a group, we call this. This is a constructed group decision. Now, this is a hypothetical decision. We say now, imagine that there was no group discussion, then, and directly a vote, then we just construct a group decision like a vote based on the individual decisions. Yeah? We need this because comparing these two, we can see the effect of discussion. Yeah? From this to this, you have already the wisdom of crowds. This also gives the effect of the discussion in the team. Then we have the all data, individual data from the previous experiment. And here also we can just, there was individual experiment, but we can just construct groups of 3 and let them vote hypothetically and see how well they would have done in that case. So then you have the wisdom of crowds in that data. I don't know what this is. At least something is still not going well. Okay, now, what do we find? I have here the broken line is the optimal decision. So this is the objective probability of guilt. This is the percentage, the proportion of convictions. So this is what should happen. Up to 80% you acquit, above 80% you convict. The red line is the individual. Yeah, this way we see that especially here they made a lot of errors, very expensive errors. The green line is the group decision making, which is much better, especially in this case. Although in these percentages you see they are a little lower than that, so they are not so good, but the difference is quite low. The blue line are the individual decisions in the group condition. You see that this already is better than the red line, which shows that by participation in group discussions, they also make better decisions in the individual decisions in subsequent periods. Conclusion from this is teams perform better than individuals. And then, of course, we want to know how good it is, what are the costs of these errors, and we do it the same kind in the same way as in the first experiment. We look at the difference between the expected earnings of your decision compared with the expected earnings of the optimal decision. And then we have just, this is all cases. Let's first look at this. Then you see that this was the average error in individual cases in cents, 55 cents. If you compare this with this group, 21 cents, that's quite a large difference. You also see that already this would be a difference. So if they, without discussion, they would vote, they also already would do better. But the difference between this and this is then also the effect of discussion. Also, this is better than that. So students who had experience in group decision making, also individual, became better decision makers. Now this is not significant. So in this group treatment, in general, you don't see a difference between group discussion in groups or just voting without discussion. However, we can look at the different cases. simple cases and difficult cases. Now, the difficult cases, apparently, is where the probability, objective probability of guilt is between 40 and 80%. So you should acquit the suspect here. In this case, you should also acquit, but it's quite easy, because not all the evidence, but it's quite logical to see that the evidence is mostly exonerating. These are easy cases because there is relatively strong evidence for guilt. Now, if we then look at the difficult cases, you see a quite high, this is where they make the losses. €1.28, so more than their earnings as a salary in that period on average. In the individual case, in the group case, it's less than half of that. All these things are significant. So you see, this makes a difference, but not so big in the difficult cases, because so many individuals make the same mistake. If you form groups of 3, then they very often 2 of the 3, or maybe all 3, will make the same mistake, so they will still make a lot of mistakes. Individuals here are still much better than individuals here. Here, this is the effect of just the wisdom of crowds, that just simple errors are not there anymore. And this is the effect of discussion, and you also see here. So for the difficult cases, it's really worthwhile to have groups of 3. They make much better decisions. Also, the discussion really adds something. However, if you look at the simple cases, then you see that discussion hurts a little bit. Yeah? So that means, especially this is interesting, but you see, of course we have all this information of the chat box, where you can just read the whole discussion. What you see very often in discussion is that some people say, oh, we should be cautious, think about this €15 we can lose, we should not convict so easily. But that means that they make better decisions here, but also maybe a little worse decisions here, because they, even if the objective probability of guilt is 85 or 90%, they still have the tendency to acquit. Okay, so what we, if you think in policy recommendations, you can imagine that we say now groups are better than individuals, but of course, yeah, it's also 3 times as costly in a sense. Yeah, so that's not so strong. But this is a very nice argument. This, for example, I'm sorry, this here, that if judges on a regular basis have to make decisions in group of 3, and that means talking with other judges about how to do this, then they also become better judges in the individual cases. So even if it is relatively costly to have 3 judges on cases, it also improves the decisions in the individual cases. Yeah, this is what I already said. Conclusion. Participants underestimate the probability of guilt in the difficult cases, but nevertheless convict too easily. That's what I said on average when they, you saw the graphs. Groups of 3 do better than individuals, partly because of the wisdom of crowds. So small errors are, rare errors are just filtered out by voting in groups, but also partly by discussion within the group, especially for the difficult cases. And participation in group discussion improves subsequent individual decisions, which is, I think, maybe the most important part of this study. Policy recommendation. They should learn more about statistics. We had the discussions about that because, of course, students who study law are also different kind of students. So some of them go study law because they really hate mathematics. And if you would say you have to do some mathematics, that is maybe also not a good idea, because some maybe quite good judges are not going into law school and study language or whatever because they really hate mathematics. But nevertheless, at least they should recognize when cases are difficult. So they should realize how it should work, and they should say, oh, this is a difficult case, I need help. Yeah? I need some others to look at it. Group decisions are not only better, they educate individual judges. So even it's costly to have 3 judges on a case, it is also has some external effects in other cases. Another thing, which is not here by the policy recommendation because it's hard to do, is that in practice, whether you have one judge or three judges is depending on the seriousness of the crime and not how difficult the case is. So it should be better if this is more flexible. That, for example, in more cases you start with one judge, and if one judge thinks, oh, this is really a difficult case, then they add two other judges. That would be better, but that is, I understand, quite hard to get into law because there's too much subjectivity and things like that. Okay, that was my last slide.